What's going on, everybody? Welcome to UW Marathon CS540 Week 6 Game Theory. If you're new here, welcome. Be sure to check nearlyblog.com and click this image here, and you are able to come to this page. So this week in Game Theory, we are mainly talking about minimax algorithm, alpha beta pruning, and non-deterministic game. So let's take a look to this course. So here I've drawn a diagram, a tree. So here is the starting point, and here are the leaf nodes with its own respective values. So for minimax is for nodes, they actually have max node or minimize node. So for example, here the first is max node, second line, which is A, and B here are actually min nodes, and third line C, D, and E and F are actually the leaf nodes here. So for the min node, it will just get the minimized value of its children, and for max node, it's actually get the maximum value for its children. For example, here the leaf node, or you could also say the terminal nodes, are 200 and 100. So in order to get the minimized value, so that is compare 100 and 200, and that is 100. So node A's value will be 100, and same stuff for B, and here's 2. And in order to get the maximum value, node S here will compare 120, and of course the maximum value here is 100. So minimax algorithm is very intuitive. However, we do have a special circumstances here. That is, what if there are other nodes here? For example, there is a node G, and node G has a lot of children. So with minimax algorithm, it will just search them one by one. However, it is actually not necessary to check node G and also node G's children. It's because for whatever value to G, the value of B here can just be less than 20, less or equal to. For example, if G equals to 21, then B get the minimum value of these three nodes are still 20, and if G here is, for example, less than 20, so B here will change to 19 instead. However, the S node here will still pick the maximum value between 100 and 19, so the value of S here actually will not change. So since the result will not change, and in order to prove our efficiency, then the whole node here, including G and G's children, are get pruned. So this is what we call pruning. And in order to introduce pruning, I like to introduce alpha beta pruning algorithm. So we are still going to use this diagram. There are a few things to take note. So alpha beta, I will just represent like this. So alpha beta is actually the value for each node, and to determine which nodes and its children should get pruned. So alpha here is the maximum value. That is maximum value we get from here, and beta is the minimum value. Minimum value is get from here. So there is a condition that is alpha should always smaller or equal to beta. Otherwise, if alpha greater than beta, then all the nodes and its children should get pruned. So let's take a look to the algorithm. So first of all, alpha is initialized as minus infinity, and beta is initialized as infinity. And the reason to do this is because since alpha will get updated during the max algorithm, so at the very beginning it will just initialize as the smallest value, which makes sense since it has to get updated sometime. And at the very beginning, only the leaf nodes here has the value, and all other nodes, or could say their parents, do not have any value here. So first, and another thing I want to mention, that is alpha beta pruning is actually using DFS, or could say depth first search algorithm. So it will continue searching here and back. So if you're not familiar with DFS, I do have a DFS tutorial in uninformed search in lecture 2. So check that video. First of all, it will go to here, and it will just pass this value, alpha beta value here, and A has not get updated since it doesn't know yet. Then you will go to C, and since this path is actually the minimum algorithm here, so what it does is actually it will pick the minimum value. So when it goes here, get the minimum value, and here is still alpha beta. However, since during the minimum algorithm will change beta value, so beta here is initialized as infinity, and here actually the data here, the value here is just 200. So 200 is smaller than the infinity, so we will get updated. So remember, we will only update when the value is smaller than beta during minimize algorithm, or the value is greater than alpha in max algorithm. So it will go back, and right now it's already get updated, and that is 200. So here, first of all, A here got a value, that is 200. Okay, so next it will, let me change the color. It goes to here. So here right now is infinity and 200. However, since 100 here is smaller than the beta value, which is 200, what it will do is it will change 200 to 100 and go back here. And right now, since A is get the minimum value, so 100 here is smaller than the yellow on 200 here, so it will update it with 100. And meanwhile, since the beta value here is already 100, while here is 200, it will update it as well. Let me just use the blue color, and it will go back. And here, what it does is doing the maximize algorithm here. Since B's value we don't know yet, so we just don't care about that. However, the value of A here is 100. So what it does at this stage is it will update the update node S value to 100. And in the meanwhile, since here the beta value here has already been changed to 100, and the value of A here is 100 as well. We don't care about B since we don't know B's value yet. So to do the maximum value, we check 100 and minus infinity, which is the alpha value here. Since 100 is greater than minus infinity, so here we are going to change the minus infinity to 100. Okay, so we have done the left branch. We're going to, by DFS, next we're going to go to this branch. So right now our alpha beta value is 100 and infinity. Then we go to this stage. Always check that alpha value is smaller than beta. So actually you can see all these alpha beta values here, alpha smaller or equal to beta. So no nodes get pruned. So here it goes down and check, since it's a minimize algorithm here, so it will compare 120 and the infinity. Since 120 is smaller than the infinity, it will update the infinity to I should have more color, man. Sorry, will be 120, and it will update the value to 120 to B first. Next, it will go to F here. F has value of 20, and compare 20 with 120. Apparently, 20 is more than 120, so it will just update it as 20. And since B is getting the minimum value of its children, compare 120 to 20. 120 is smaller, so it will update the value of B as 20. However, there is a magic thing here happens. We can see here the alpha beta 100 is actually greater than 20, which is the beta value here. So everything after node B, no matter there is node G or node, for example, X or something, and all the nodes below, or you could say the children of node G, X, and all other nodes under B, all get pruned. That is so crucial, but we have no choice. Next, what it does is right now the value of node B is 20 here, and the alpha value is 100, but it just cannot get updated of beta value here, so it get pruned and just go back here. And next we are going to compare, since X here is the maximize algorithm, so it will compare its children. So here's 100 and here's 20 to get a maximized value, which is 100. And as the alpha value of S is still 100, while the beta value is still infinity. So this is the alpha beta algorithm. So as you can see, all the nodes here, every procedures are undetermined. So which is to say every move is optimum, or you could say deterministic. Yeah. So it will just choose the either minimize or maximize value at each stage. But what if there is a percentage or probability to choose between the children of the node? So that is what we call non-deterministic game. So let's take a look for that. So here is the PowerPoint from our lecture notes. And for non-deterministic game theory is, for example, here we no longer is the maximize or minimize algorithm to determine the value of the node here. Instead, we have the probability to their children, and each path has their probability. And as you can see, if we added all these probability together, which is actually equals to 1. So all the time, this probability, if added together, must be equals to 1. So here, let's take a look for it. Here the value, I still use alpha beta. So here alpha beta is let me initialize it as minus infinity and infinity. Then go to this. Okay, we don't know the node here yet, so we're going to move forward. However, the things here, unlike doing the minimize algorithm, we just calculate the estimated value. So that is 0.5 times 4 plus 0.5 times minus 20, minus 16, minus 8. Yeah. So right now we get updated the value here as minus 8. And since it is a minimize algorithm, so we're going to update our beta value here to 8, which is, sorry, minus 8. So that is the value of the current node. Then we go back. Since right now this is the maximize algorithm, -8 is greater than -infinity, so what we're going to do is we just say goodbye to -infinity, and we're going to change it to -8. Then we come to this stage. This node we don't know its value yet, so DFS move to this node. Still don't know its value yet, then we just move forward. And here I think it should be the maximize algorithm here. So in order to calculate the value of this, so it is 0.8 times -5 plus 0.2 times 10. And who can tell me what is this equal to? 2 minus 4 should be -2, right? Yep. So it will get updated of this node, the value of this node to -2, and it will, and so here is still -8 infinity. Here is -8. Oops. 8 infinity. Since it is the maximize algorithm, and we will compare -8 and -2. Since -2 is greater than -8, then we're going to change -8 to -2. Probably I'll change another color. Then we come back and compare. Since this is a minimized value, a minimized algorithm, we compare the value of -2 and infinity. Since -2 is less than infinity, -infinity, I'm sorry. So, infinity. So it will update it as -2. Every time we will check that -8 is smaller than -2, so we won't prune everything out, and we continuously go to this step here, and it is still the minimized algorithm. So we're going to compare +3 with -2. However, since -2 is smaller than +3, so it won't get updated. So here the value here is -2, and here is +3. In order to get the value for this node, which is to get minimized value, and it should be -2, since -2 is smaller. And we come back to our starting node, is to get the maximized value. So between -8 and -2, -2 is larger, so it will get update -8 to -2. So these are all the values for the nodes, and also there are alpha beta value for non-deterministic games. So I think this is the end for game theory tutorial. Hope you guys have some fun and learn something. If you have any comments, questions, or anything, please feel free to leave comments below. Otherwise, I will see you in the next tutorial.